Hey guys, Absolute 5 here again. So on day 3, we're reviewing what a piecewise function is today. So specifically, we'll just go over an example to really get an idea of what does it mean for a function to be piecewise. So remember yesterday I was talking about the vertical line test to determine whether or not something is a function or not. Piecewise function, they are functions just in certain conditions. Like there are certain condition scenarios that they do work and where they don't work. I'll give an example right now. So this example here, let's say our function f of x is equal to two cases where 1 minus x, this is the first case, if x is less than or equal to 1, x squared if x is strictly greater than 1. So what does this mean? This means that whenever I have two different cases, like this, hold on, I'm not done writing the example, hold on, let me just finish this. And we're supposed to evaluate f of 0, f of 1, and f of 2, and sketch the graph. All right, so let's understand something here first. When the question is asking us to evaluate at f of 0, at f of 1, at f of 2, and sketch the graph, this means that these are your inputs that you're going to chuck at this machine. But here's the thing, there's two specific machines right now that are going on. There's one, for example, that's 0 and 1, where if x is if x is less than or equal to 1, that means you use this function. If x is strictly greater than 1, like 2, 3, 4, you use this function. Okay? It's kind of like you have to know, it's giving you the exact instructions what you need to do. So let's take f of 0 for this case here. F of 0 will be equal to this function, so 1 minus parentheses 0, which is just 1, okay? F of 1 is 1 minus parentheses, 1, which is just 0. And the last one, f of 2, now we have to use x squared, so 2 squared is just going to be 4. So now, ideally here, what you want to be very aware of is that these are your points. So meaning, when you're plotting these points, right, your first point here is going to be, let me erase the top part. I know what the function is, so I know what's going to be. So let's gather this. So f of 0, the coordinates for that is going to be 0, 1, because we put in 0 and we got an output of 1. F of 1 is going to be 1, 0. F of 2 is going to be 2, 4. So remember what the two functions are, 1 minus x and x squared. Remember those two cases. Remember those two cases, okay? So as we're graphing this function, right, this piecewise function, here's my x, here's my y, 0, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay, negative 1, negative 2, negative 3, negative 4, negative, of course, that's what I'm saying here. Label this real quick. Oopsie 2, 3, 4. Okay, so remember our function here, f of x, is going to be 1 minus x and x squared. Again, if x is less than or equal to 1 and x is strictly greater than 1. That's what our function is here. It's always good to indicate what you're drawing so you don't forget. So 1 minus x, so let's see, 0, 1. So we're starting at the origin and we move up 1 point here. That's our first point. That's f of 0. F of 1 is you move over 1 point, and that's the second point. The last point is you move over 1, 2, and you shoot up here. Let's see here. Oh, no, that's not right. That's not right. You know why? I made a mistake. That's not right because, remember what I said, pay attention to your function? This here is a straight line going down because the negative sign in front of the x. That's why it's shooting, the function is going down. And it's a straight line because 1 minus x is always a straight line. Just depends on the sign that will determine if it's going down or if it's going up. Now x squared, what's x squared? It's a parabola. It curves. So that's why when we make this incision here, it's going to look something like this. But the point at 1, 1 is going to be open because we already stated that if 1 minus x exists or coincides with this function, therefore, for this to be a function, 1 to 1 and on to, this point here can't exist, because otherwise, if we take the vertical line test and included that point, this will not be a function. So like I said, piecewise function can become functions. They just have to sort of modify themselves in certain situations just so that they can work. Otherwise, they are a function, just not 1 to 1. So I hope this example was good for understanding what a piecewise function is, how to always consider what are the scenarios of what you want to do for them. So I want to thank you guys for watching Absolute 5. I'm Roger Palomino, and math is infinite.